Hello everyone. So for this video, we're going to go over everything you need to know for lab 2, and in that lab you're going to be making a multiplexer, and you're going to be doing that by instantiating some you're going to be combining a bunch of little multiplexers to make one big multiplexer, and that's one way of doing it. There's another way of doing it with combinational logic. So we're going to review that. And then I guess at the end of this video we're going to be doing a test bench just to show you how to simulate with Vivado. Okay, but just let me just pull up the screen. Okay, let's see if it's working. Okay, perfect. All right, so I guess let's review about combinational logic. Okay, so for every combinational circuit, it's very simple. You're just gonna think about it like a box. We're gonna have some unknown thing in here. You're gonna have some number of inputs, could be this many, and then you're gonna have outputs. So yeah, these are your outputs and inputs. For example, let's say we have two inputs, two outputs. Okay, so we got our inputs and our outputs. And so you might be thinking, well, what are these inputs and outputs? Well, for the inputs and outputs, it's always going to be ones and zeros. And the way you model all the combinations, and there's a finite combinations of inputs and outputs. So there's four combinations of inputs and four combinations of outputs. You're going to model that with the truth table. So our inputs, let's label this one. This is input A. This is input B. This is output X1, output X2. So A, B, these are our inputs. Our outputs can be X1, X2. And with the truth table, that's where we get to choose how the circuit behaves. So, okay, so the input's always going to be the same combinations. First one, 0, 1, 0, 1, and then 0, 0, 1, 1. And if there was a third one, it'd be 0, 0, 0, 0, 1, 1, 1, 1. And then all of this would be duplicated, but we don't have that many inputs. And the reason why that pattern is that way is because for the inputs, we just want to have all possible combinations. So we have that. There's two inputs and there's only four possible combinations, so that's why that's there. Okay, so let's say whenever both A and B are 0, we want this one to be 0 and this one to be 1. Let's say when A is 0 and B is 1, we want them both to be 1. And then let's say when A is 1 and B is 0, we want them both to be 1. And then let's say when they're both 1, we want them to be 0. Like, let's say we want that to be what it is. So this is go through it. So this one. So if we make A1 and B0, what's going to be here? Well, X1 is going to be 1 and X2 it's going to be 1. And then for this one, 0, 0, x1 is 0, x2 is 1, and yeah. So that's how that works. Okay, so now you're thinking, okay, so we created our truth table. This is right here. We got our basic model. Now you might be thinking, well, how do we know what this is? And if you haven't, well, you've all taken logic design, so, and for anyone, just, I don't know, I try to make these videos very simple, just so a person off the street can just watch this and learn. It's, yeah, there might be someone on YouTube watching this who wants to learn logic design. So, okay, but yeah, so there's logic gates, and yeah. Um, Let me think. Oh, okay. So once you have your truth table, the next step to create your circuit is to create a K-map. So let's do that. Hold on now. Okay, the video will probably cut out eventually because I only have the free trial of this recording software, unfortunately. So, but it's okay. I can always just start it back up again. Okay. Oh, what am I doing? Okay. So to make a K-map, just memorize that when you have 2 inputs, you're going to use this kind of K-map. And this is just something you just need to memorize. And then it's going to be 0, 1, 0, 1, 0, 0, 0, 1. And then, here, let me explain what happens when there's more inputs. If you see, so we had a truth table stuff. The K-map you're going to use when there's 3 inputs is going to be this one. And if you're really familiar with all this stuff, you can go ahead and skip to a later portion of the video. But for anyone who doesn't know, because I mean, you'd be surprised with what people don't know. So it's good to just explain every single little detail so anyone, literally anyone, can do this. Okay, so if you have 3 inputs, this is going to be the K-map you use. If you have 4, so you got your stuff and your outs. 4 could be like this. And, oh yeah, I could point. Okay, and these patterns right here, you just need to memorize these. And same thing with these here. You could use your own pattern probably, but I don't know, this is just kind of the standard one. So I would just stick to this. Okay, so let's get back to our initial one. So when A is 0, and B is 0. Oh, and also, one important thing to know is you might be asking yourself, well, how many K-maps do I need to realize the circuit? And the answer is the number of K-maps you need is going to be dependent on the number of outputs. So this is the K-map for X1. Hold on. Almost done there. And And this right here, it's going to be the PK map for x2. Okay, let's do the x1 one first. So when a is 0 and b is 0, 0, 0, x1 is 0. Because this is this. Okay, when a is 0, and b is 1, x1 is 1. When a is 1 and b is 0, it's 1. And then when they're both 1, 0. And okay, let's do the next one now. So hold on. Let me reconnect. I'll probably edit all this out soon. The reconnection. Okay. Okay, now we reconnected. And ooh, I can change the color. Whoa. Okay. So let's do the K map for x2. When a and b are both 1, x2 is 0. And then as you can see, the rest of them are 1. Okay, so now that we have our K maps completed, um now it's time to circle stuff. So for this first one, and you circled them in multiples of 2, no multiples of any other number, unless it's like 4 or 8. It's got to be a multiple of 2. So no multiples of 3 or 5. So this one, that would be circled. These would be circled, and these would be circled for the and you cannot do something like that. Like here, let me show you what is bad. You cannot do that. That does not work. Okay. And again, if this is all really trivial, I apologize, but I just feel like it's important to show every single detail because when I went through these classes last semester, more than 2 semesters ago, a lot of people had no idea how to even do this. So, so yeah, I'm just gonna say everything, not skip any steps. Okay, yeah, so we have our K maps now. So now we need to make the equations. So for x1, so we're gonna look. Okay, so one thing to memorize is whenever there's just one thing circled, you just kind of look up at this and then see how it correlates to that. So it's 1, so then it would be A. So this right here correlates to A. And then this one, oh, wait a minute, hold on. Oh, hold on. It correlates to A. Oh, yeah. Yeah, I almost really made a stupid mistake there. So, yeah. Yeah, this is why it's important to show every single detail. Okay, but anyway. So, yeah. Let me just show. So, this circle is kind of like correlating to those two. So, yeah. So, for here, it goes to 1, and then that 1 is on the A column, so it'll just be A. And then for the B, it's in the B side, but instead of just writing B, you do B prime. So yeah, AB prime is that circle. And you can use a bar or a tick. Both of those mean the same thing. So yeah. Okay, for the next one, so whenever you do that, you do a plus sign, and then you start in the next one. So because it correlates to the 0 on the A, it's going to be A prime, and then B, because correlates to there. I'm just kind of saying how I think about it. So yeah. And then, oh, wait, redo. Okay. So then this A prime B. And then for x2, okay, here now you're going to see what happens when multiple things get circled. So for this first one right here, pretty much the more things that get circled, the less terms there are. So for this one, because you see how there's a 0 in the circle, like right there, and then a 1, and those are different, that's going to mean that the A gets canceled out. So like it's going to be, oh, and then B prime, I mean, is the 0 on the B side. The 0 on the B side is constant. So that's the only thing that stays there. Because the A values are all changing throughout that area. It goes from 0 and then 1, but the B is always 0. So it's just going to be B prime. So yeah. And then for this other one, okay, so for this other one, the B values are changing. It's 0 and then 1. So it's only A prime. So B prime plus A prime. Okay. Now that we have our equations, it's the final step, which is to just build the circuit. So, um, so let's do that. So we have our different gates, which is going to be AND gate, and then OR gates. So for this first one, we're going to have to address this term. It's going to be A ANDed with B prime. Because whenever it's just stuck together, you just assume that it's using an AND gate. So yeah. So this right here correlates to this. And now let's do this one. So it's going to be A bar B. So this whole thing relates to this. And this to this. And then now, as you can see, this entire thing is being ORed with this. So that's why we put them both into an OR gate. And then this will give us our x1 value. Okay, so now that that's done, we just need to do it for x2 now. So now ask yourself, are we going to need an AND gate for x2? Or are we going to need just an OR gate? Well, we just need an OR gate. So it's going to be B prime, A prime being ORed, and that will give us x2. Down there. Okay. So now that that's done, oh well, let's just get some water. Oh, I gotta reconnect. Um, okay. Okay. So yeah, now that it's reconnected, you might be thinking to yourself, well, what does this B bar mean? Well, what that or A bar. So in electrical engineering, there's this thing called a NOT gate, where if you put a 1 in here, you get a 0 here. If you put a 0, you get a 1. And if you put an A, you get an A bar. If you put in a B bar, you get a B. And yeah, it just reverses everything. So you could just leave it, like, for this second one, it could technically be rewritten like this. E, A, and yeah. So this whole thing and this whole thing are the same because of that. Just maybe obvious to some people. I just feel like it should be said. Okay. Now that we have our circuit, oh well, actually, really all you need is just your equations. Drawing this, that just helps you visualize what's actually going on. But once you have your equations, you can start simulating right away. So now let's do that. Let me open up Vivado. See if I can minimize this. Minimize. Oh, wait a minute. Oh. Oh, it might have been covered up earlier. Oh, so apologize about that. Okay. All right, you guys can see my mouse. I don't even need the pointer thing. Or it's red, so it's better. So this whole thing right here is for x1, and then this is for x2, and yeah. But in reality, once you have the equations from the K-map, you can just start simulating in Vivado right away. And so yeah, you didn't even need to do this, but for your test that Dr. Morton will ask you, you will likely need to know how to draw these because this is the circuit that gets synthesized at the end of the day. Okay, minimize that. Got scared to minimize that one. Or, I don't know. Okay, so we're gonna create a project. And you might be asking yourself why I didn't do the setup process beforehand. And the reason is because you can always just do it if you go into settings and then here, then you can select what you need. And in order to simulate your circuit, you don't actually need to do that. But in order to get it put onto an actual board, then you do. Okay, create a design source. We will call it NF for normal file. Okay. Let me just try and go kind of quick because I don't want to take too much time in this video. But it's important to explain everything though. Okay. Now that we have this, okay, so we have our module. Right now we'll just leave it, we call it NF. So in this area right here, that's where you put your inputs and outputs. We have A, B, X1, and X2. So we're going to do A, B, X1, X2, and then you're going to do input A, B, output X1, X2. Okay, so yeah, now that we've got our inputs and outputs mapped out on here, now it's just time to do some combinational stuff. So we're going to do the way you write an equation is using a assign statement. So let's do that. So assign x1, because that's our output, equals 2, and x1 is equal to a ended with b naught, and then ORed with that. So we're going to do a, logical and then we're going to do b naught. So not b, and then we're going to OR it with a naught, and then with and with b. Okay. So this whole thing correlates to this whole thing right here. And then I'll just do the next one. Assign x2 is equal to. So it's going to be, we're going to have an ORing of two things. And it's going to be not A and not B. Those are the two things going into the gate. Okay, so now that we have that done, this is all of the code that is needed to generate these two circuits and to build this little device here. So let's save that, but then we want to simulate it. So I'm going to show you guys how to write a test bench. Do this, create simulation source. We'll call it TB for test bench. To get created. Okay, here it is. Okay. So the test bench works a little differently in that you don't put anything there, but you do reg A, B. Hold on, let me just write first and I'll explain. Okay, so your inputs were A and B. So you're gonna do reg AB. You're gonna make those be register values, and then you do wire for x1, x2 because your output. You're always gonna make your outputs wires and your inputs registers. Okay, so now that that's done, we need to instantiate the thing we want to test. Let's copy this down. Control V, and then I think you just do NF, and then you can just name it whatever. Okay. But let's name it IN0 for instantiation 0. Okay. So now we want to do an initial begin statement. Just reconnect this real quick. Actually, for now, we don't need to reconnect because I'm not going to write anything yet. Okay, but the initial begin, then end. Okay, so in the initial begin, that's going to be where you write all of this stuff to simulate. So essentially what we want to do is test all possible values for A and B. So you can do that with the for loop. That's a more advanced way of doing it. Man, there's just so much to teach. Like, we could do it both ways. You know what? We'll do it the hard way because in future labs, that will save you a lot of time in this class and other classes. Integer I, and then you're going to do for I equals 0. I is less than 4 I plus 1. And then instead of using braces like this, you use begin and ends for the for loop. Okay. So what you're going to do is A, B equal to I. And the reason why that works is you might be thinking, oh, well, this is a register. Well, how many bits long is that register? When you just do reg A and B, it makes it a 1-bit register. So you could define it like this, like 1 tick B Or is it? Hold on. Actually, no, never mind. I just got confused there. Okay. So yeah, whenever you do just reg AB or just reg A, it makes it a 1-bit register. If you do something like this, then then that's a 4-bit register because it goes from 0, 1, 2, 3, 4. But when you don't do that, it makes it a 1-bit. So the bit of A is there, the bit of B is there. I is going to be 0 at first, which is 0, 0 bitwise. And then during the next iteration, it'll be 1, which will then change this to be A is 0 and B is 1. And then when I is 2, it's going to make A be equal to 1, and then B be equal to 0. And the reason why that is, actually, hold on, I guess okay, been here 35 minutes. Let's reconnect, just I guess explain why this works. So, say we got a for loop. So as I is going to go to 0, and then 1, and then 2, and then 3, and then like repeat. Yeah. So we're making A, B equal to I. During the first iteration, I is equal to 0, which is also equal to the binary value of 0, 0. So then it assigns this to A, and then this to B, and then when I changes to 1, it will be this, and then that will be assigned to A, this to A, and then this to B. And when this is 2, it will assign 1 to A and 0 to B. And when this is 3, it'll do that. So that's why that whole thing works. Okay. Let's minimize that for now. Okay. And then we want a delay. The way you make delays, Vivado, is do this and then the number of milliseconds or some nanoseconds or something. But let's just do 100. I think the way you define what this actually, yeah. These units right here are in terms of this. So it's 100 nanoseconds, I think. And then this just shows what it rounds to. So if it was like 100, I don't know, point or like something like this maybe, or just some weird number, it would round using this. But the actual units in this is 100 nanoseconds. Okay, so we have all this. So we're going to save. And then now we're going to run our simulation. Oh, let's see if it worked. Okay, that's promising. Okay, so the way we're going to check if that's right or wrong is by looking at what our truth table was. So we know our truth table, when A and B are 0, x1 is 0, x2 is 0. Move this over. Oh, man. Okay, so here, when A and B are both 0, x1 is 0, x1 is 0, that's good. And then x2 is 1, so that's good. Here, when A is 0, A is 0, and then B is 1, B is 1, they're both 1. So they're both 1, that is good. And here, this right here is corresponding to this third row. So when A is 1, I kind of wish the pointer could just go off, but it can't. So you have to look at my mouse. So when A is 1, B is 0, B is 0. They're both 1. X1 and X2 are 1. That's good. So yeah, whenever it's green and it's high, that's 1. Whenever it's black, that's 0. And you can also look at the numbers here. So yeah, 1, 1, I mean 1, 0, 1, 1, 1, 0, 1, 1. And then let's look at the final one. So it's gonna be 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0. So yeah. So what that means is we have successfully created this device in Vivado. And the final step now is to discuss, well, there's a lot more to do actually. There's discussing instantiation of multiple modules, which is going to be very important for this lab. And then there's how to physically map it with the constraints file, which is another important thing for this lab. But it'll all be explained here, and if you power through to watch this entire lecture, the lab should be incredibly easy. This, yeah, oh, yeah, for your lab, there's multiple ways you can do it. So you're gonna have a mux, or actually, I'll discuss that at the end. I'll discuss it at the end, yeah. Okay. Let's minimize this for now. Okay. So yeah, we ran our simulation. We have the correct values, so we know this works. And so now let's look at the elaborated design to see what got made. Okay. So yeah, it kind of came out similar to what we wanted. Let's compare that with, so this whole thing right here is what Vivado interpreted our circuit as. There's multiple ways to realize the circuit. You don't have to use AND and OR gates, but yeah. Hold on. Okay, so we got this this right here seems like it correlates to this, and then this to this. We got our B going in there, yeah. And then we got our A going into an inverter. Yes, that makes an A naught. Yeah, so this and this are the same. It just looks different. Okay. So now that that's done, this is there. So we've gone over the whole process to understand it all. Oh yeah. Now, now it's the final part, which is making a actually, let me just write down all the steps because this is a lot. Okay. First thing we'll do is do constraints. So this is going to be pretty important. Let's see, F for constraint file. Okay, loaded. Takes a while to load usually. Okay, so as you know, you just Google it. And you copy it. And then you paste it. Paste and paste it in here. Okay, for some reason there's a lot of stuff. Actually, stuff that's already there, you could forget it. But switches. So we have our inputs. Hold on. Oh, we gotta reconnect. Oh yeah, that's my list of stuff. So constraints, instantiations, and then simulator online. Okay. So the constraints. So we have A and B, but let's say we want to map. Let me just get the form. Okay. So let's say we want to map the constraints to the, well, let's say we want to link what we made in Vivado to this board here, and we want to map A and B to a physical component because they're inputs. Inputs are buttons and switches. So let's say we want to make these switches correspond to A and B. When it's switched like this, that will make it be a 1. Switch like this, that'll make it be a 0. So let's do that. And then the outputs will be in the form of an LED. So right here, those LEDs up top will be our outputs that we will physically map it to. Okay, so the switch, let's use these two. We only need two. And what we called it was A and B. These are our inputs, so A, B. So we've completed all that. Now we need to go to our LEDs. We only need two LEDs because there are two outputs. And they were called X1 and X0. I mean X1 and X2. X1, X2. Bothers me. But I don't know. It looks weird how there's that. I don't know. We'll see what happens. If something bad happens because of that. Okay, now it looks better. I think I might have accidentally tapped it or something. Okay, so we're gonna do that. Oh, and now I'm gonna go to settings here. And this is gonna always be the same. It's gonna be family. I would recommend just writing it down on like a little piece of paper somewhere. Like this. Let me just use just in case. Like, yeah. Because you're always gonna need to use this. So it's gonna be Arctic 7 package CSU um XC7 A100, and it's going to be this one. So yeah, just write that down. That will always be the same for this board. If you get another board, you will need to look up what the specific things are for that. So I'm going to click apply, and then OK. Now, it's time to generate the bit stream, because we did all of that. Let me get my adapter now. Plug it in. Okay, so I plugged it in. Make sure to have your power switch on. And then, okay, let's see if the bit stream generated correctly. It's still generating. Yeah, that always takes a while. Okay. Generated. And now, what I'm going to do is we're going to go to open the hardware manager. Open target, auto connect. And now we're going to program the device. Okay, it seems to be working. So let me pull up this. So this right here is our truth table. So right now, let me just turn off the light. That'll make it easier. Okay, so it's hard to. Okay, so right now, which one do you think the LED that's on represents? It's going to be X2, so that one is X2. And yeah, the switches are both on the 0 location, but if we change them both to make them, let's make the, so right now, it's going to be where I think the X1, yeah. So right now, B is 1, I think. Is this one? Hold on. Let's see if I can just physically hold it over. Kind of afraid to do that because I think it glitched last time. You gotta be real careful. Okay. Yeah, this is way better. Okay. So this switch right here, that corresponds to our A. This corresponds to our B. This LED corresponds to our X1, and this one to our X2. Right now, they're both turned off, so we are 0. Let's change. Let's use this input combination where input B becomes 1. So when we do that, A is 0, that's why it's in that position. B is 1, that's why it's switched up. And then both X1 and 2 are 1s, which is why both the LEDs are on. And then let's change them back to 0 again. Now when we do A 2 1, it turns on. And when we do them both 0, when we do them both 1, what do you think is going to happen? Both LEDs will turn off. So yeah. So we have physically mapped this truth table to the FPGA. And that's essentially what you're going to do with your own thing in lab 2. Okay, we're making reasonable time. Okay. Now okay, yeah, so I showed you how to do constraints. Now we just need to do instantiations. So let's say we want to make another one of these. Let's copy that. Paste that right here. But we want to make a device that cascades it like this. Well, you could look at the input output behavior and then make a whole separate truth table. Or what you can do is this thing called instantiating. So let's do that. So whenever you want to instantiate, you're going to make a new module, call it module top. And module. And then all you're going to do is copy the name of the one you want to instantiate. This is bottom one NF. And 0. Then, well, we're going to do our inputs. Or, hold on. Let me bring this up. Okay. So we have our thing we want to instantiate here. Let's call this I1, I2, O1, O2. These right here, you might ask, well, what do those get marked as? Well, we're going to make them wires. So this would be wire. We'll make it wire 1. wire 2, wire 3, wire 4. So those are going to be the physical components that we need to map. So here, it's going to be I1, I2, O1, O2, input, I1, I2, output, O1, O2, and then wire 1, 2, 3, 4. Okay, so now we are going to need 3 instantiations. And the reason 3 is because we're using 3 times in our example. Okay, so this first rectangle, it's going to have inputs. It's going to have input I1 going into the place where A would have been. And from here, A goes first, but we want I1 there. I1. And then the next input is B. It goes in the second spot, which we said to be I2. And then what comes, and then here is X1. X1 is going in place of wire 1. And then the place where that would have been X2 is wire 2 now. Okay, for this second block right here, the input that would have been A is now X1. I mean, is now wire 1, because this whole thing, that X1 and A, they're connected. It's just a wire. So we're going to put wire 1 there now. And then the next input where B would have gone, that's wire 2. And then the output is wire 3, and then wire 4, I think. Yeah. And then wire 3. Okay, so wire 3 is where A is. Yeah. Wire 4 is where B is. And then in the very last one, O1 and O2 are where X1 and X2 go respectively. So yeah, that is all. So that right there will create this. It'll create a chain of those 3 blocks that we made. Like this module right here corresponds to one individual block. And then this top module combines them all together. So let's save and then generate a new bit stream. Oh, actually, no, that won't work because we would need to. Actually, would it work? I don't know. Let's see. I think it would work actually. If it doesn't, it won't matter. We'll deal with that later. Thinking it will work because it's just 2 inputs and outputs. So it's gonna map it to the same spot. And it'll be interesting to see how it changes though on the board. But what we really want to see is the schematic that gets generated. Okay. Well, I guess while that's generating, I can show you the next thing. So this right here is a very good simulator that I like to use. So remember how we had these two circuits? Well, if you want to simulate it without the Vado, because that can be hard to make a test bench, you just use this. Like, look, so we're building this first one. Actually, hold on. We only need two inputs. A, and then one for B. Where's the NOT gate? Okay. So that right there builds this, builds this. This top one is our A input. So this is building the X one. So when, hold on, reconnect. Oh no, he had failed. Oh well. We'll we'll deal with that later. Now let's resume this. Okay, so we want to see what happens when both of them are 0. So when A is 0, A 0, it goes X1 is 0. Let's make B1 1 when they're reversed now. So A is 1 and B is 0. X1 is 1. Good. So what happens when they're both 1? According to the truth table, right here, it should go to 0. And it does. So we know that the circuit actually does work. And then the bottom one would be very quick to build. Just need an OR gate. And it takes the inversion of both. And according to the truth table, it will always be 1 unless input 0, 0 goes in. So 0, 0, 1, 1. The only when they're both 1. Okay. So this right here, this output is for X2. This one is for X1. And when we simulated it, that it worked. That the truth table actually works. So yeah. This gate is this gate. This gate is this gate. This is this. This right here is X1. This is this. And this is this. And this top one is A. And this bottom one is B. And then this inverter converts the normal A in, or this one converts, yeah, this right here is for here. because B goes in, but we want a B bar into the gate, so that's why that's there. And same thing for the A. Okay. So yeah, now simulated it. Showed you that. Now it's just time to take your instantiations. Okay. Let's see what happened. It could be that there's all this other stuff. Let's just delete all the stuff we're not using. So that could be it. I don't know. Oh, I know what it is. This has to be I1, I2, O1, and then O2. Let's cancel that. Okay, so we're going to generate the bit stream, and this time it will work. Here, back. Hmm. It's always annoying how long it takes. Um, There's these chips. These chips are amazing. And this Vicky's jalapeno chips, they are the best. Like, I love those chips. Those chips with some nice sweet tea, that is like the best combination for a snack, in my opinion. So yeah, definitely try them one day. Oh yeah, so that was our problem. Just program the device. Oh, well, this is good that this happened because now you can see the solution to this problem. Yeah, you just go in there and then you look for a bit stream, and then yeah, that's how you fix that. Um, so yeah, And I think it's permanent device again. So yeah, and then on the board, it's doing different stuff now, which is good. But what we really want to look at is the implemented design. Okay. And I hope the right thing comes. Oh, beautiful, beautiful, beautiful. It's showing up perfectly. So yeah, this right here. Let's pull up our thing. So yeah, it got created beautifully, exactly how we wanted it to. And yeah, it's just beautiful. Okay, so yeah, it's all working good. So now that's what instantiation is, where you make one thing and then combine a bunch of them together like that. Um, okay, so we don't really need to be in Vado now. Last thing to do to get you guys ready is to discuss how all of this is relevant to what you're going to be asked to do. So, for the second lab, you're going to be asked to make. Let me just make it nice. You're going to be asked to make an 8-to-1 mux. I don't even know if that's 8, but 1. Connect. Okay, let me just draw it neater. Okay, so 8-to-1 mux. And so pretty much what happens is these are our 3 inputs. This is the output. I guess you can actually, all of these are inputs, but the only ones we will map to switches are these, I think. How did we do it last time? Anyway, or maybe, hmm, I'm not too sure how he's gonna have it be done, but I'll just explain it best I know. So we're gonna have a multiplexer. A multiplexer is a combinational device, which means it can thankfully be modeled by a truth table. Anything that can be modeled by a truth table is easy and simple because all you have to do is make a truth table with your inputs and your outputs. This one, there's gonna be um It'd be 11 inputs. So you're gonna have a bunch of stuff here. And there's gonna be one output. But let's go through it completely. Say this is actually we'll call this A, B, C, D, E, F, G, and H. And then we have S1, S2, S3, and an O1 for output 1. So how would it be? So O1, actually, no, these are inputs. These are inputs. This is the output. Yeah. So when all of them are 0, what is the output going to be? It's going to be output A. A can be either a 0 or a 1, depending on how we define it. What about 0, 0, 1? Well, then O1 will assume the value at node B. What about 0, 1, 0? Well, then it's going to be C. What about 0, 0? I mean, hold on. 0, 1, 1. Well, oh, also, oh man, there's another important thing to say. But I don't know, so that'll be D. Hold on. E, F, G, H. And then what's going to be happening is you're probably going to be given these values as hard set ones and zeros. So this is 1, 0, 1, 0, 1, 0, 1, 0, 1, or something, or 1, 1. Then you just take all this and put it in place of there. And then you can do your K-maps and get your equations and get it done. And then there's also instantiation, where you can get a bunch of little muxes, a bunch of 2, 4 muxes, get multiple ones of them, and then figure out how to connect them together such that the end behavior of them all is the same as one of these. See how there's 4 things here and then 4 things there? So those 4 add up to have 8. And then 1, 2, 3, 4. How would that work? And then I think in your lab it's actually a different multiplexer other than these, but yeah, it's one of these kinds of multiplexers, I think. So you're gonna figure out how to combine them all to like have the effect of one. And once you figure out how to do that, then hold on. Yeah, it's commonly available information, so I'll just share this with you guys. So you, okay, yeah. So there it is. So you're gonna have to figure out how to make one of these little muxes. And then once you do that, you're gonna instantiate it similar to how we did earlier with that completely made up circuit I made. So it's very important to know how to make one of those little ones. So I guess I shouldn't. Here, let me pull my thing. So yeah, you need to know how to make your little mux. Think about it. You have one output, one output, um, three inputs, or actually no, you have one output and one input. And then let's say this is 0 and 1. Then the truth table is going to be, it's 01. So when I is 1, when I is 0, it's going to select the top line, so that'll be connected there. And when I is 1, it's going to select the bottom one, so this is going to be 1. So what you're going to do is you're going to make a truth table from that. I mean, your key map. How would you do a one thing key map? Confusing. Because earlier, we know when it's ABC and ABCD, use this one. And when it's just AB, you use this one. But what about when it's just one? Would it be like this? Reconnect. Let's try and be quick. Or actually, no. I'll let you guys figure that out on your own. Because I can't do everything for you. But let's see, Mux equations, just to get you guys started. There's lots of stuff online. Yeah, like this thing right here. This will really help you out. And actually, yeah, that's the equation for the 2-1 mux. So yeah, that right there. That's the truth table. Yeah, so just use that as your building block. So that's one way of doing it. You can also just make the truth table yourself for the for the 8-1 mux and completely bypass the instantiation. But but yeah, that's another way of doing it. So yeah, that should be all that you need to know. If you have any questions, feel free to email me and then we can just meet virtually maybe, or we're all just like if you really need help, we could probably do a Zoom session, but if it could just be answered by email, that would be best. Yeah. Okay. 1:30. 1 hour 30 minutes. Long video, but all right. Until next time.